working with functional connectivity data and think of in future you want to work, then in research paper you definitely see this kind of picture, which is the better and attractive way to show your functional connectivity data. But here, most of us are unaware how to create these kind of images. But you don't need to, because I'm here for you. So let's discuss what we need to create these kind of images. First of all, we need node file, and the second thing, we need edge file. Let's discuss about each individually. So for node file, what is node file? Of course, the node file represents the nodes, which depends on atlas by which you create FC. This figure shows the 90 nodes figures because this is based on AL atlas, which have 90 regions of interest. Then, if we talk about each file, which contains each of your FC, these are connectivity values of your FC. It can be anything, the correlation or fixtures and the scores. But how we know how many edges our FC have? So the simple answer is, if we are using 90 by 90 FC, the edges will be 4005. But how we know that? So the first thing, you have to multiply 90 by 90. It will be 8100. Then you have to do minus 90 from this. Why we are doing minus 90? Because 90 is number of nodes, and in diagonal we have the highest connectivity, as the diagonal represent connectivity for the same node. So we don't need this. This is not useful information. So we will minus it. Then, as a connectivity is a symmetrical matrix, which means the upper triangle value and the lower triangle value are same. So taking only one triangle value is your edge. So for that, you can divide your result with 2, and the answer will be your final number of edges. The next thing is, when you want to visualize FC, first you have to think, what is your goal? What you want to show your readers? So the one thing is only node information. Here, like this figure is showing node information with different colors for the different values. Also with the size, you can see which node is big, which node is small, have small value. This information can be anything, the nodal strength, or if you are working with graph theory, it can be any graph topology like degree centrality, betweenness centrality. It's all depend on your research. Second thing is node and edge information. This figure is showing two information at the same time. The color representing the nodal information and the edge color with the gray scale representing the strength, or you can say weight of your edge. So the lighter color means the edge have very less weight, and the darker color have that edge have highest weight. And the last thing is, you are only representing your edges. Here, nodes have no color, no size. This means this figure is only representing edge information. You can see each have different weight. So some edges are thick, some are thin. It means the edges have different weight. So here we are showing only edge information. We have neglected our nodal information. So why we do? Why we must know about this? Because when our goal is to show only edge information, then we just need to create edge file, and we can use example file of BrainNet UI for the node information, because our node have no meaning. But if we are going to show the node information like this case or this case, then we have to create the node file for our own data. We don't have to use the example node file. That's why it is important. We must know what we want to show. So for the Visualizing of FC, we need BrainNet viewer, and for BrainNet viewer, we need two files. The one is .node extension, the other one is .h extension. Now we will further discuss how to create these two files, the node.h, node. Let's move on to our MATLAB window where we will see how to do this work. Let's create a new script, and here we will generate any random matrix A which will be 90 by 90 representing 90 by 90 FC. We can execute, and now we have A which is 90 by 90 matrix. Now what you have to do to see you have to open notepad of your computer. Every computer have notepad. You have to copy your 90 by 90 matrix from viewer window and then open your notepad, then create a new file and paste your data here. After pasting your 90 by 90 matrix data, you have to do one thing, is save it in any folder where you are working. Then you can name it anything. Like example, I'm doing it H file, and then you have to please make dot steric H. You have to write. Steric H. You have saved it, but it will be not saved due to steric. But you have to write steric and then try to save, and then remove steric and save it. So it will be your H file which is saved in your folder. The other way is for the H file is go to the BrainNet viewer which you have downloaded, go to the data and then go to example file, and then based on your atlas you can choose, like I'm working by 90, so I'm taking AL atlas. Then we go to the H folder and select any H file. This is already copied, please do not change it. Copy it in your folder so you can modify it for your data. You can paste this one here. Open this, contain edges which are like example edges given by BrainNet viewer. You can copy your data, which should be 90 by 90. Please remember the data should be 90 by 90, otherwise you will not get your BrainNet viewer results. So keep in mind. For the node file, again you have to go where you have saved your BrainNet viewer. Then you can open your A90 or any, but we are using 90, so we will take 90 atlas node file. Copy it, please do not modify it directly in the example. Copy it anywhere else. Then open it with notepad. Then copy this and open Excel where you can modify this node features. Copy the actual data and paste this data into Excel sheet. Then you can, these three column. Please do not change these three column. These are X, Y, Z location for the each region which is built in for the BrainNet, and these are the names. Of course, you will not allowed to change this name. So keep in mind that starting three columns are the location of these regions and the names are based on AL Atlas. So we are not allowed to change this name, but we can change these two values. This line will represent your node feature, which can be anything like node strength, any property which you have calculated for your data. So you can change this line for each region and make it like 1, 2, 3, anything, any value you, but I'm just writing random just for example, but you should write the actual feature, actual value of your node information. And this second column is to grouping your nodes based on their network or anything, or make any cluster. So you can make based on cluster, you can give colors in BrainNet viewer, which will be easy for the readers to understand that these areas belong from visual network, these areas are involved in cognition, these areas are involved in memory or sensory outcomes, something like this. So it is to make the cluster. So after this, copy this data in your notepad and save it. Then go to BrainNet. As I don't have BrainNet in my MATLAB, so I will install it. I will go add with subfolders. Then go to the file folder where you have your BrainNet. I will give the link in the description how to download BrainNet. You can get BrainNet from that link. So here I have a separate folder for MATLAB function, from where I will take BrainNet and select the folder. So save it. Now my MATLAB have BrainNet viewer, and so I just write a simple command which is BrainNet, and it will open BrainNet window. Sometimes it may take time because it depends on your processor. So here we have BrainNet. In each file I did one mistake which I will reveal because I want to show most common mistakes we do. Here we can take any surface template which is also given by BrainNet. In the examples file you can take, this is the most common templates. Then we will upload our node in each files which we have just created. We will upload our node file, then our each file. So now we will reveal my mistake. First, let me show you some settings. Here you can do any changes, any setting what you want. You can take any layout by for which you want to work. You can make your surface dull, anything. You can light your surface, increase your this surface. So most commonly is lighter one, so you enhance your edges and nodes. Then for the nodes you can change your settings, and this you can change your colors, your threshold. As I said, when you are using example file from BrainNet viewer and you don't have any information, then please make it equal size so readers can know that this node have no information. And for age you can change anything, any color. You can customize your color. You can you use threshold. You can make your own matrix for your edges. When especially we do this when we are working for two sample t-test, if you want to show the edges with positive and negative color only, you can apply threshold to see. Now we have no results, and behind my meta you can see there's something with red. It means I purposely did not create it 90 by 90 matrix when I was creating each file. Why? Because I want to show most of the time we don't create 90 by 90 matrix and we think the BrainNet viewer is not working. See this red screen. This error is means our H. So this is the most common mistakes. So please create 90 by 90 each file. Now do all the settings which you need and apply. So see, here are your results. Please keep in mind, always make sure that your H file is 90 by 90 or any region sized which you are working. It should be symmetrical, otherwise you will face so many errors. Here is our figure is loading all edges. You can go to the options to change the colors, to apply any given thing. And one thing, if you want to save it as a high pixel image, you can increase your DPI, so when you will save and zoom it out, your figure will be very clear. There will be no blur effects. This was all about the demo how to create each file, node files. If you have any questions, please do comment. I will clarify it. And please keep in mind, everything depends on your research. Node color, node size, node is your research. What is your research telling? Please make your files according to that. What is your H file information, what is your node file information, it depends on your research.